Hello everyone, this is Mr. Muhammad Imam and this is Oxide channel. Today's part is an important part for the IB students, which is to know the difference between the ionization energy, electron affinity and the electronegativity. So let's start with the first part or the first concept, which is the ionization energy. So let's make a deal together. Guys, we must know that atoms tend to lose or gain or share electrons. Why? To be more stable. So this is the deal. The atom must lose or gain or share electrons during the chemical reaction. The main reason behind this process is to be more stable. How to be more stable? To be more stable, it means that its outermost energy level will be completely filled with electrons. It must contain 8 electrons. So suppose we have to explain the ionization potential energy, or the IE. Suppose we have a positive nucleus surrounded by energy level which contain 2 electrons. Okay? This atom will be referred by M. If this atom decided to lose one electron, so it must absorb a quantity of energy. It must absorb a quantity of energy first, then it will lose this electron. This quantity of energy is called ionization energy. Okay. So to change to a smaller part, or we can say it's an ion, it will be smaller, referred by M positive 1. Well, this positive ion maybe lose another electron, lose one electron like this. So it's supposed to have another amount of energy, Q, which is called also ionization energy, to change to a smaller part like this, referred by M positive 2. Okay? So the quantity of energy absorbed, the Q here, is called ionization energy. Yes, that's right. We can differentiate between them, guys. This is the first ionization energy, and this is the second ionization energy. Okay, we observe that the second ionization energy is much bigger than the first ionization energy. And also, if there is a third electron is lost, we found that the third ionization energy is bigger than the second, is bigger than the first. Why is that? Because by losing electrons, the atomic size decrease. Yeah, that's right. So the atomic size is inversely proportional with the ionization energy. If the atomic size decreases, the ionization energy it will increase. So it's a note, very important note. We found that there is an inverse proportional between the ionization energy and the atomic or ionic size or radius. You can say that it's a radius. Okay, let's study the trend of this property in the periodic table. So in the period, what happens to the atomic size in the period, guys? Yes, the atomic size decreases, mister. So here in the period, the ionization energy increase. But in the group, as there is an increasing in the atomic size, in the group, as there is an increasing in the atomic size, so the ionization energy will decrease. This is the first part of our session today. Let's move to the second part. Which is the electron affinity. Electron affinity. That's right, which is the opposite for the ionization energy. Suppose we have a nucleus for an atom, a nucleus for an atom, which contain 7 electrons in the outer level. We can say that it's a fluorine or chlorine. Okay? So it's like N. We can refer it as an N. This atom tend to gain electron, that's right. So it will gain 1 electron. So to gain electron from outside, it will, yes, that's right, release a quantity of energy. By the way, after gaining electron, what happens to the atomic size or the ionic size? It will becomes bigger, that's right. It contains 8 electrons in the outermost energy level. We can refer it for it like N-1. So this quantity of energy here is electron affinity. So we can define this electron affinity is the quantity of energy that lost when the atom, yes, that's right, when the atom gain electrons. So this is the electron affinity. Let's study the trend in the periodic table, as also it's related to the atomic size. This is the period, and this is the group. In period, we found that the electron affinity will increase, but in the group, we found that the electron affinity will decrease. And the reason for the atomic size, by the way, the reason is for the atomic size. So by increasing the atomic size, we found that after, like we studied before in the case of gaining electrons, when it gained electrons, the atomic size increased. So the electron affinity will increase by decreasing the atomic size because the attraction force increases also. So the gained electrons will be exposed to a stronger repulsive force. Let's move to the third part for this session, which is the electronegativity. That's right, the electronegativity. Here, the electronegativity, it means that the tendency of an atom to attract the electrons of the covalent bond toward itself. So the electronegativity appears only in case in the presence of bond. May be found in the ionic bond, may be found in the covalent bond, as we will see. It will the presence of the bond of the bonds. Okay, so let's see if we have an atom of Na, another atom of chlorine. So atom of sodium will lose of one electron. It will move to chlorine. Here we can say that chlorine has higher electronegativity while sodium has lower electronegativity. Also, like in HCl, it's an H here, and Cl here. There is a covalent bond between both of them. There is two electrons revolve around chlorine, then revolve around hydrogen. We will find that it spend much time. That's right, it spend much time for the vicinity of chlorine. That's right. So chlorine here will be higher of electronegativity, and sodium will be lower in electronegativity. By the way, here it appears the polarity. That's right. Here we can say that it's a polar compound. The polar compound here, it means that there is revolving of electrons around the chlorine in much time in the vicinity of chlorine away from hydrogen atom. It take, by the way, partial positive charge, partial negative charge, but here it will take a positive charge and negative charge. Thank you so much, guys. I hope you enjoyed in this session and you learned from or to know the difference between the three concepts. Thank you so much. See you.